Alright guys, we made it to our first Friday here. So I know today I talked to you guys about taking a quiz. We'll see how it goes. I put together a quiz in Google Classroom, and you guys will submit that and I'll try to grade it. We'll figure it out. We'll go from there. I just want to see where we are in terms of understanding of the material at this point. So I just wanted to do a quick review of what the key concepts were for 9.1, 9.2, and 9.3. Okay, so from the beginning, we talked about some quadratics. We want to know, when we're given a quadratic, we know our standard form is y equals ax squared plus bx plus c. And this information here gives us, these values give us information. So whether a quadratic opens up or down, we graph, depends on a being positive or negative. So if a is positive, it's going to open upward. If a were negative, it would open downward. All right. Then another piece of information A gives us is how narrow or wide is it, just for purposes of getting an idea of what it looks like. The closer A is to 0, the wider it gets. The further A is from 0, the quicker it's going to shoot up, so the narrower it is. So the bigger A is, it gets narrower. The smaller A is in terms of absolute value, the wider it is. If you check out Desmos and just punch in a bunch of different quadratics and let it graph it, you'll get the idea on that. You'll see what's happening. Then when we actually go to graphing quadratics, this is what we need to find. We want to find the axis of symmetry, which our axis of symmetry, and I'm going to give you an example of this from the warm-up today, it's just a dotted line that will cut our parabola in half. And to find the axis of symmetry, it's the x value of the vertex. That's why we put x equals, and by the way, remember that vertical line is an x equals the opposite of b over 2a. So we just plug that information in, the opposite of b over 2a. Here's a, here's b, and that will get us our axis of symmetry. It'll be some point, that x value. Then to find the vertex, which is either a maximum point if it is opening downward, or a minimum point if it's opening upward. Okay, to find that, we take this value right here, the opposite of b over 2a, plug that into the quadratic for x, and get that output. That'll be the vertex. Then to sketch a graph, we create a table of values, and we use our symmetry. So we might plug in 0 is always an easy number. We'd get c, we'd plot that point, whatever it is. And then we can use symmetry from there. If c is like 1, 2, 3 away, we go to the other side, 1, 2, 3 away. So once you find one point, you're actually finding 2 because of symmetry. You might plug in another point, maybe you're 1 away, so you'll be 1 away on the other side, and you just draw your parabola opening downward. The zeros of a function. Okay, this has a bunch of different names. It might be called the roots of a function, the zeros of a function, or even the x-intercepts. That's just the values where you would be crossing your x-axis. All right, they're going to become really important over the next couple of sections. That's what we're going to be trying to solve for when h equals 0, or when y equals 0. Right, what's our value of our x? They're going to be the roots. All right, then we went on from there. We talked about solving equations by taking the square root. That was yesterday's lesson, and what that was is if you had a quadratic like 3x squared minus 25 equals 0. The first way we talked about solving that, which kind of is a more of a longer, arduous way, is to set this equal to y, graph that whole function, and look to see where you cross your x-axis, because that's when y is 0. That would be way too much work. All right, we really don't want to do all that work. So what we decided, or what we talked about, is if there's no b term, if it's just a and c, we can solve this algebraically. We just get the x. Let's put this as, instead of 20, something that's divisible by 3. Let's just say it was 24. I would get that to the other side, divide by 3, divide by 3, x squared would equal 8, and then we would take the square root of both sides. If this guy over here is not a perfect square, no big deal. We just plug plus or minus the square root of 8. Or you can round that to whatever value you want. And remember, when we're solving the quadratics this way, if you end up with x squared equals negative 10, we can't take the square root of a negative number, so you would say there's no solution there. Okay? And lastly, we talked about our vertical motion model. And in the vertical motion model, we know that h is our ending height. It equals negative 16 always. That's the force of gravity times t squared plus v, which is your initial velocity, times t plus c or s, that's your initial height. So in the warm-up today, I said a toy rocket is shot upward with an initial velocity of 272 feet per second from an initial height of 2 feet. And we can plug in h would equal negative 16t squared plus 272t plus 2. And if you think about what's happening there is, if we shoot up anything, it's going to go, as time goes on, here's your height, it's going to get to its maximum height, and then it's going to come back down again. So when they ask you to find, in a problem like this, the time it takes to get to the max height, that's just your opposite of b over 2a. That's going to be the time it takes to get to the max height. The max height itself will be the h value of the vertex, which we just basically find that opposite b over 2a, which is the time. Plug that in. That'll find your height of the max height. And then if it asks you to find the time it takes to hit the ground, we pretty much just kind of guess and check until we get to 0. Next, you see what I did on the warm-up today. But basically, just take your time and kind of double it. And on the warm-up, it took 8.5 seconds. The opposite of b over 2a ended up being 8.5. So I knew if it took 8.5 seconds to get up, and we only started 2 feet off the ground, it's going to take about another 8.5 seconds to come down. And when I did the warm-up, it was slightly over 17. And that would be the time it took to hit the ground. And we know that when we hit the ground, our ending height is 0. So it's one of the roots there. All right. So just kind of walking through this piece right here on the warm-up today. I asked you to graph this guy. So when you graph a quadratic, we always want to follow this routine. We want to find the axis of symmetry. That's the first thing we want to do, which is x is going to equal the opposite of b over 2a, which equals negative 6 over 2 times 3, which is 6, so that equals negative 1. Then next thing we want to do is find the vertex. So I just take this guy, negative 1, and plug it in. Now be careful when you plug it in. I did on the calculator. I basically just plug in 3 times negative 1 squared plus 6 times negative 1 plus 2. Notice, this one's not so hard. I mean, it's negative 1. I can figure that out mentally. But when you have other numbers, I just use the calculator. I plug them right in with parentheses and do the math. And when I did that, I ended up getting negative 1 again. So there was my vertex. And then at that point, all right, I'm going to go ahead and create what I do then is I grab and I actually will sketch the vertex just to get an idea where it is, use my axis of symmetry to figure some points out. So when I graph that, all right, it's negative 1, negative 1. Let me just draw this here. And it's also opening upward, so I kind of adjust where this guy is. I'm at negative 1, negative 1. There's my line of symmetry. Okay, so then at that point I just create a table of values. 0 is always a good number to plug in. If I plug in 0, I'm going to get 2. So at that point, 0, 2. Using symmetry, if I'm 1 away here, I'll be 1 away there. And then I just really need one other point. So maybe I'll plug in positive 1 and see what ends up happening there. When I plugged in positive 1, I end up getting 11. It was 3 squared, so it was 3 plus 6 plus 2, 8, 9, 10, 11. And I think at that point, I think on the warm-up I was off my paper. But 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my line of symmetry. If I'm 2 away, I'd be 2 away. And I just kind of sketched my parabola from there, swooping down. Okay, that's it with that stuff. That was the warm-up from today. All right. So what I'll do is, in classroom, if you want to check it out, there's a quizzes to do as a warm up, as a practice before you take the quiz, the actual quiz. I'll attach a quiz in classroom. It's mostly multiple choice. There's a couple short answer in there, and just submit that, and then we'll go from there. Remember, you could be working on your test corrections. If you have them home, you could be working on your week. The next packet that I gave you, the Common Core, I don't remember exactly which weeks they are, but you could be working on that week packet. And then also we have the reviews. The focus right now, though, is on the 9.1, 9.2, 9.3. Next week we're going to continue into 9.4, 9.5, and 9.6. And we'll see where it leaves us on Friday. All right? Have a good weekend.